Sir, are you able to see the screen now? That what I'm playing?
Yes.
Yeah, this is just a small video, and you can see this how the system looks like this when you keep this block panel and equipment rack keep aside. So this is the a main equipment rack. That is what I said just said. This is Euro rack in which cards are provided, and this is relay rack in this which houses for relays, and a global reset button. This is main equipment rack with Euro rack and relay racks, and this is block panel for block operations with a block telephone. And this is for user terminal, and even operations I will show. This is for user terminal to see the data of this block instrument, and it is 2 out of 3 buzzer. This is how it looks when we look from a front view or a front side. So this is the rear end of the system or rear view of the system. If you open the back side, you will see that this is back panel or back rear plate, and this is a scrambler card on the back side of the relays. So these are terminal blocks used for wiring. These are terminal blocks used for wiring block panel inputs and the station signaling inputs. We can easily detach and attach them when required. So now this particular ACCU, the first card is ACCU as I said, and this is connected between even channel and voice channel of OFC. So here we can see it is showing 2 digits. One is the top 2 digits. The top digit is displaying 6 and the bottom is displaying 9. And here 6 means it is a signal to noise ratio level. It indicates that 6 means it is good. The channel is good. And 9 means the rate at which it is transmitting data to other end block instrument. So it displaying 6 and 9 means it is transmitting the data in a good channel at a speed of around 9600 bits per second. If this is the bottom channel is even channel, here we can see the power supply, even status, even health, and everything we can see here. So now it is connected between a voice channel and an even channel. And the second is communication card. Here it is providing power supply to, you can see that DC-DC converter 1 is okay and DC-DC converter 2 is okay. And there are two redundant DC-DC converters so that in case if one fails, the system will continue working on with other DC-DC converter. We can see the status of 5 volts available or not, 24 volts available or not, communication status, and all we can see. And input module A and input module B, input module C. These three are very same cards, similar cards. Here we can see the status of the inputs wired to this block instrument. Here both front and back contacts wired so that the status of those front and back contacts, if anything is that if particular LED is glowing means that particular contact is closed, maybe front contact or back contact. As we are wiring both contacts to detect the bi-state failure, we are wiring both front and back contacts of each button, each relay, each key, so that it is easy to detect a bi-state failure. So all relays, all contacts, I mean all buttons, all keys, front and back contacts are wired to block instrument. So that status is shown here, whether it is closed or not closed. So this is power supply CPU module. As I said, there is a provision for internal health check of power supply. Here, if it falls less than 4.5 volts, this LED glows. If it is more than 5.3, it is close. So it is required that we have to maintain the supply between 4.5 to 5.3 for ideal operation of the for trouble-free operation of the system. Here CPU, there is a 7 segment digits too. These digits will display error code. So like if there is any error or failure in the system, these digits will display the code. So these indicate inter-processor communication means and its validity. IBC interblock communication run means whether the card is okay or not, we can see. So uh, these are all three sets of input cards and CPU cards, and another is voter card. This voter card just checking the outputs of these CPUs and delivers the output to non-vital and vital cards. So it is a global reset button with a counter. So this global reset button is used uh, to power on to bring the system into function in case if you initially power on the system, or if any card is replaced or any relay is replaced or replugged, we have to apply this global reset to bring the system into function. We can see the status of relays, and even LEDs are provided on the top of the relays to indicate the status here. So these are the total 11 relays, but this relay, repeater relay, and this CPC, we can see that it is they are QNN1 relays. Both are the relay, both are provided on the same base. Two relays are provided on the same base. So similarly, this relay also repeater. This is also provided on the same base. So TGT and TCF, these two are latching relays, and remaining are all neutral relays. Only TGT and TCF, these two are latching. Remaining all are neutral relays. So this is a EKT key, only used in a single line for enabling the shunting in a single line. For double line, this is not used. So this is the backplate or rear view of the system. This is what I said, GDT card, second level of surge protection device, SPD, that is what we are calling. This is a GDT or SPD. Here, voice lines are terminated here, voice channels are terminated here, and even lines are terminated here. Since this block is connected on voice channel and even channel, here even lines are terminated here and voice channels are terminated here. From here, through this card, the output is extended to, the communication is extended to main motherboard through this ribbon. So this is another module. This is for used for connecting user terminal, data logger, and a local PC for that purpose. So this is actually our lab. It is block instrument is at our lab. So this is a scrambler card. What I said, this is a scrambler card, or it can called as a digital input card. So we can see here all the inputs from station, all the inputs from block panel, or readback inputs are connected to this scrambler card. And from this scrambler card, so from this scrambler card, the inputs are extended to a main motherboard or input cards. So through these ribbons. So the back side of the relays we can see here, and the status of relay, this particular relay, whether it is up or down, indicated by this LED indication PCB. So the status we can see here. So this is fuse panel. So this fuse panel is used for distributing power supply from this panel to all other modules, all other sub modules, subsystems. Here also we can see the status of these fuses on this LED indication panel. So this is a isolation transformer for galvanic isolation, and this is a surge protection device for power supply. For communication lines, it is not shown here, but for communication lines, the SPDs will come here in this place. This is for power supply we are showing, and similarly, and they are also quite similar to this. They are provided here for power lines, data lines. Sorry. So these are all terminal blocks. So the left of the screen that we are seeing, this is factory wired. So this is all factory wired. So from right is it is this is the wiring that we have to do at station. So before for interfacing purpose, this is the right side of the screen we are seeing. This is interfacing wiring, and left is factory wired or pre-wired that is done at office. So these are all pre-wired. So this is block panel. So this is a block panel. It is a single line block panel, and how it looks like this. And we can see that now the station master key is out, and so now we cannot operate this panel. Now so SM key is in now, so that we can operate the panel. Now we are trying to take line clear here. We can see here a number of indications we can see here. Now the block status is line is closed here. It is indicated by this line closed, and the status of LSS is shown here, and signal normal indication and shunting key indication for single line, and signal normal of other end station is shown here, and of course axle counter status is shown here. Now SSBPAC is okay, so means it is letting green. So TGT and bell buttons are pressed for line clear. So now we have received line clear. This communication link fail. This indicates the interblock communication with the other end block instrument. If it is blinking, means communication is okay with other end block instrument. If it is glowing steady, means there is a communication fail with other end block instrument. It has to blink. So it has to blink like this. The communication link has to blink like this. So means the communication is okay. So this is maintainer terminal. That's what I said. We can see the status of block instrument and block section. Now the block section status is line closed, and the line is closed at 1349.17. So now the status of block section is closed. So now we can see we can operate this. We can see various information. We can do modem reset from here. So these are this is the information, and we can see we can get from this maintainer terminal, which is very useful. Input status, all input status we can see, all error codes, all errors generated by the system we can see. States means relay states and all we can see. State of the block instrument, outputs, status of outputs we can see. The power and the temperature of the system we can see. Communication status, all these parameters we can see. So here we can see we have three inputs like CPU A, CPU B, and CPU C. The status of reset counter or a status of a bell button we can see here. The status of bell button is now its front contact is down and back contact is up. The status of bell button in a CPU B is its front contact is down and its back contact is up. The status of bell in the CPU C is front is down and back is up. Means all three CPUs are reading the same and all are same. So this is to know the status of inputs, means both front and back contacts. So here we can see the power and the temperature of three CPUs, as we have CPU A, CPU B, and CPU C. The power supply of CPU A is okay within the limits. CPU B is within the limits. CPU C also within the limits. We can also see the temperature whether it is within the range or not. So all three CPUs are reading same temperature now. So this is to know power and temperature. So now we can see the errors generated by the all CPUs. Now we can see that in CPU A there is an error. CD break means there is a communication break with other end station, and of course again it is made, but there is a CD make and break. So these are different errors that we can see here. So these are status of vital output cards or vital output relays. Let us take a TGTR, TGT relay status. In CPU, what it is saying is its front contact is down and its back is up. Similarly, in CPU B, TGTR is uh, front is down and back contact is closed. TGTR in CPU C is also saying the same thing. Again, in the voter card, like I said, it checks the outputs of three CPUs. It is also verifying the same status is there or not. You can see that the status what CPU is saying and the status what voter card is displaying is same. Voter card is also saying the same thing, that TGTR front is down, back is up in all these three CPUs. Means CPU whatever CPU is saying, that is same in voter card. So we can see all output module status here, like TGT release relay, TCFR, advanced starter control relay, repeater relay status. So these are the error codes, and it's their description are displayed here. If there is any failure, let us say if there is a bi-state failure of a track circuit. So let us say home signal ATPR bi-state failure. Then the system will display a 40 error. Means there is a bi-state failure of home signal ATPR in the block instrument or the input wired from station signaling. So that if there is an error code of 40, then we can see that there is a bi-state failure of uh, there is a bi-state failure in home signal ATPR. Similarly, if there is a display of 41 means home signal BTPR failed, BTPR bi-state failure. Similarly, if there is a bi-state failure of TGTR, then 42 is displayed. So error code, along with the error code, description means the reason for the error code is given here, so that it is easy to detect a failure or identify a failure. Uh, for. So not only this, all this diagnostic data, all these errors are transferred to a central place through existing data logger. From there, if there's an error code, along with the error code, the reason for the failure, along with error code, they are sent as notification or SMS to the field staff to through existing SMS network of data logger or existing SMS system of data logger, so that all SSBPAC information or failures we can get as notifications are in our mobile. The status of SSBPAC, everything we can get the failures, error codes, its descriptions, reasons we get. So these error code stickers are provided on the side of the block panel, so that in case if there is any failure, it is we can quickly detect the reason for the failure. So in this session, I have not covered installation and its maintenance. Installation portion I have not covered. Maintenance is actually, since it is an electronic system, maintenance is not much required for this, apart from checking the apart from checking the earth values or cleaning the system, because power supply relays and all their self monitoring is there. So for that, no maintenance is required. So this is what I thought I would share with you. So if there are any questions, and you can ask, so that.
Sir, in case of BPSC with USBI,
Sir.
we use MUX actually for transferring the information.
Uh-huh.
Here, what we are using from one block to another?
Yeah, it is actually that automatic media changeover unit is there, na sir. That transfers data from one block to another block. Just I will share 1 second, sir. So here you can see this, sir. Just there is no mux here. We just use the automatic media changeover to transfer data from one place to another place, because all the data is in soft form only in this, unlike the TFSBI, because there are 32 relays. To repeat the status of those relays from one point to another point, they have to use mux to reduce the number of data lines required. For this, here it is, all the block logic is achieved through software only, just like EI. So the data is transferred in the form of data only between two block instruments on a communication channel. That's it.
Okay. Okay. So anybody, if who want to question, to ask any question, can ask. Any doubt, we can ask. Sir, can it be integrated with the CTC?
CTC, now this spec is not permitting, sir, directly.
Okay. Okay. Sir, one question is in the chat box. I think
Yeah.
you can see.
Chat box, just I'm looking at. I think, how does the system prioritize the communication type that is connected to it? Actually, we are using two channels. Let us say voice channel of OFC and even channel of OFC. We know that even is better than voice, so that by default the system is connected to even only. System selects even channel. If there is a break between even channel, seamlessly the system transfers to voice channel, because internally the ACCU itself has its own monitoring system. It monitors both connected channels whether they are in connection or not, like even and voice. Since even is better than voice, by default the data transfer is done on even. If even fails, immediately, seamlessly, even we cannot find it whether it is shifted or not. Immediately it transferred to voice. Even there will not be any break in the communication. So similarly, if there is a fiber channels or fiber and a voice, fiber is better than even voice channel. Again, there also the system default connects to fiber, and if there is a break in fiber, then it seamlessly transfers onto voice. So like that it happens. And similarly, if there are two voice channels, one is on a copper cable and second is voice channel, audio channel of OFC. Default it is connected to audio channel, and if audio channel breaks, it transfers onto copper cable. It is prioritized like that based on the channel type.
Sir, it means both station are 4 ways available communication purpose.
Yes, sir. Both station for, sir.
4 ways. That means voice channel and your channel. Any one failure, then
No,
alternately another
yeah,
channel
yeah.
will come.
Possibility is there, but right now we have two channel audio, this ACCU. We can connect any two only at this moment, either voice or media, this one voice channel or even or two fibers like that we can connect. So if
Okay.
you have, yeah,
In
if
case
you have
anyone failed, means it automatically switch over, sir.
automatically switch over. That is why it automatic. No, nothing to do anything there.
Okay, sir. Okay, sir. Thank you, sir.
Excuse me, I have two questions.
Sir, one more question in the chat box.
Yeah, sir. I will see. So what is the rating of 5 number of users distributing power to the loads? All are 2 amperes, sir. 2 amps. All those 5 are 2 amperes. Each 2 amps.
So, any more question, please?
Yes, I have a few questions.
Sir.
Line clear conditions, you told 7 conditions are there. In that, HATPR and HBTPR cleared at both stations.
Yes, sir.
If it is upline and downline, what is the need of HATPR and
Yes, sir.
HBTPR at both stations?
Yes, sir. Yes, sir. Yeah, sorry. That is for single line only. For double line, it is not applicable, sir. Yes. Yeah. Thank you.
What about SSBPAC and data logger time? Is it different or?
No, actually, this data block instrument is synced to GPS only, sir. Nothing to do with the data logger time because we have GPS receiver for this.
Okay.
Yes, sir.
There is no sync, then how we will sync the data of this relays of SSBPAC and with the data logger?
Yes, sir. Data logger time that is synced to GPS of test room. I mean, because one module we are providing at test room CMU, na, sir. So data logger is synced to that, and this block instrument is synced to local GPS receiver. If GPS is not available there, then data logger syncs with block instrument syncs to data logger time. That is it. If
That means both are same.
yeah,
Same.
both are same, sir. Same. Don't find anything there.
Okay. Is it required to program the card before inserting whenever any failure happened?
No, sir. They are permanent coding for single line and double line. Nothing to do anything. It is not like even. It's like a pre-embedded card. It is.
So any input card or CPU card,
No, nothing.
water card is defective. It will defaultly matches or we need to program. I heard somewhere we need to program before inserting into the specific block instrument. Is
Yes,
it
sir.
like that?
That program is done at office level only. If you want to replace that card.
Actually, if you take, I have 100 blocks, 10
Yes,
block
sir.
sections.
Yes, sir.
In that, I have 10 pairs. Is it possible to replace from one block section card to another?
Yes, sir. Yes, sir. Except
it-
yes, sir. Except motherboard, any other cards are transferable, interchangeable from one.
Okay.
Yes, sir.
Only
Only motherboard only we cannot change from one to other and other block instrument because in the starting I said section ID is there for each block section. There is a permanent ID that but block section only.
Okay.
So if you receive any other motherboard and we have to change that ID on the motherboard before inserting into the block instrument. That is the only thing.
Means there is no need of programming. Just
Nothing,
we
sir.
need to
Nothing.
change the ID.
Because our purpose is same. Everywhere the function is same.
So what are the things proved in SNOEK? Only other station HA.
Yes, sir. Other station home signal GNCR and advance in case if it is single line.
Okay. In case double line?
Double line only advanced GNCR there and home GNCR. I said.
There is no need of ATP.
Not required, sir. Not.
Okay.
Not.
Okay, thank you.
Yeah, thank you, sir.
So what is the full form of SNOK? Actually, description of SNOK?
Yeah, signal normal of other end station, sir, other station. Detect, actually, indication it is SNOEK.
Okay.
Signal normal other end indication.
Okay.
Yeah, somebody posted in chat, sir. I think any care to be taken while maintaining FET or LVT during normal. No, sir. Nothing to do. Any care to be taken while maintaining FET or LVT during normal course of maintenance done by technician. Nothing, sir. For this, not required. Auto changeover communication card stays. Yeah, it can be displayed in maintainer terminal, whether it is connected to whether it is CD okay or not. The status we can see. The first actually we have seen that only modem status CD okay or not. That we can see, sir. Communication status we can see through maintainer terminal. I think in Guntakal only we have 22 block sections. Yeah, I will send this PDF, sir, and yeah, you can drop your mail IDs here if anybody wants. I will mail, or I will mail to.
Sir, those who have registered already, I have email IDs of those persons.
Yeah,
Others can write here their email IDs.
yeah, I should.
Okay, then we can wind up.
So, sir, if there are no more questions, we can conclude here, sir.
Sir, how much cost, sir, single line and double line? I asked one question.
Sir, you have mentioned. Sir, actually, I don't look into these commercial things. And if you send your number, I will send that to my commercial team so that they will directly discuss with you. In fact, really, I don't know.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Okay, sir. Can we conclude now? Sir?
Yeah.
Okay, so thanks to everybody, and thanks to Mr. Srihari for giving nice presentation. Thank you, everybody.
Yeah, thank you so much, sir. Thank you very much.
Thank you, sir. Thank you, sir.
Thank you.
Ah.